Have you ever wondered what exactly phenol is? Well, let's get into it.
Let's take a look to the structure and properties of phenol. Phenol is an organic compound that contains a hydroxyl OH group attached to the hoop of the benzene ring. Phenol is also known as a monohydroxybenzene and recognized as benzenol or carbolic acid. Its molecular formula is C6H5OH. Phenol is similar to alcohol, but in fact it can form stronger hydrogen bonds, which tend to be more soluble in water and have a higher boiling point than alcohol. Pure phenol is a white crystalline solid and a colorless liquid that have a strong odor or disinfectant-like. Next, let's move on to phenol nomenclature. Naming the phenol is basically using the similar rules of aromatic compound. For example, organic compound named phenol is when one hydroxyl OH group is directly attached to one of the carbon of array group, which known as benzene ring. So, we need to always remember to prioritize the phenol, then benzene as the parent when naming the organic compound for phenols. Phenols can be classified into monohydric, dihydric, and trihydric. Monohydric is when that organic compound contains one OH group. Let's take a look for the example. So there is two hydroxy group attached directly to the carbon of benzene ring, so it is a dihydric phenol. So to name it correctly, first we need to write down the parent name, which is phenol. Next, we need to indicate the position of the substituent of the benzene ring, which is the two hydroxy group attached at carbon number 1 and number 2. So the full name comes out as 1,2-dihydroxyphenol. In addition, disubstituted organic compound can be named using prefixes such as ortho when the substituent at carbon number 1 and 2, meta at carbon 1 and 3, para at carbon 1 and 4. In this case, there is two different substituents attached to benzene ring, which are one hydroxy group at carbon number 1 and one methyl group at carbon number 4, which turns out to be paramethylphenol, or commonly known as paracresol.
These are some of the physical properties for phenol. First, phenol is colorless and crystalline solid. Next, phenol has sweet and acrid odor. The last one is phenol moderately soluble in water. Chemical properties for phenol. In part A is solubility and pH. In a clean test tube, about 1 ml of phenol and 1 ml of water had been transferred. The mixture had been heated in a water bath. The solution had been tested with a blue litmus paper. Then 1 ml of sodium carbonate solution had been added. It had been observed whether the solution had become homogeneous at room temperature and after heating. At the end of the experiment, we can observe that phenol is insoluble in water at room temperature. After heating, phenol is partially soluble in water. Next, after addition of sodium bicarbonate, no physical changes. Lastly, blue litmus paper turns slightly red. In part B, 1 ml of phenol had been dissolved in 2 ml of ether and then followed by addition of a small piece of sodium. If any gas had been released, the gas had been tested with a burning wooden spleen. At the end of the experiment, we can observe that gas bubble formed, flame extinguished, and pop sound produced when tested using burning wooden spleen.
Chemical properties. Experiment 4B, reaction of phenol, part C, D, and E.
Part C. First Roman, an aqueous bromine water solution has been added drop by drop in an aqueous phenol. It had been observed whether there had been a physical change in the mixture. To Roman, preparation of excess of bromine water with phenol. Aqueous phenol had been added drop by drop in about 5 ml of bromine water until a physical change had occurred. Observations. 1 Roman, addition of bromine water decolorized. 2 Roman, addition of excess bromine water with phenol, white precipitate form.
Part D,
2 to 3 drops of neutral ion trichloride solution had been added into an aqueous phenol solution. A mixture of phenol 1 ml and water 1 ml had been heated in a water bath to prepare an aqueous phenol. Observation: 2 layers of solutions form, orange solution at the bottom and violet at the top. Part E, 2 ml sodium bicarbonate had been added to 1 ml of phenol. The mixture had been observed if there were any gas bubble or effervescence produced. Observations: 2 layers of solution form, no physical change.
Thanks for watching.